Good afternoon. My name is Infante. I'm from Instituto Superior Técnico, maybe it's the major engineering university in Lisbon, in Portugal. And I will talking about structural optimization that we are performing in a passenger train seat, and we are using finite element analysis to support the optimization and also to obtain the stress and strain distribution. This work is performed by Alves, by João Marques, José Aguilar Madeira, Ricardo Baptista, and myself, Infante. Okay, this study is included in a huge research project with the name Ferrovia 4.0, and the main objective of the project is to develop new processes, products, and services. And in our case, we are included in the work package number 5, as you can see here. Maybe not, because it's very, very small. But the main objective is to produce seats, light seats with a huge mechanical strength and also using green materials. For today, I will present only the part of the structure, but of course we are dealing also with the remaining parts of the seat. In terms of objectives of this study, is to reduce the seat structure mass and profile footprint while not compromising the stiffness and the majority of the mechanical properties, namely the mechanical strength, the stiffness and the toughness of the seat. Another objective is to integrate several sensors, namely accelerometers, strain gauges and a microphone to obtain and to control the condition of the structure and also to control the comfort of the passenger. In this moment we are comparing with the current seat. The current seat frame has the total mass of 8 kilograms, as you can see here. To compare the different models that I will show it to you, we use the boundary conditions defined in the standard OIC 566. Namely, we applied a boundary condition in the headrest, as you can see here, with a total value of 1500 newtons, normal to the surface. We have applied also a vertical load in the armrest, a horizontal load in the armrest also, and we apply a distribution load in the seat function, as you can see here, with a total of 1000 newtons. The first model that we designed, okay, and I will show you only 3 models. Of course, we have a lot of models. I will show you the first one of the middle, and one after the optimization. The first one, it was this, and we use a main profile from steel with dimensions of 30 per 30 per 2 millimeters of thickness, with a total mass of 6 kilograms. The problem, as you can see here, maybe not, but is the displacement in this direction, in the normal direction. And for this case, the finite element obtain a value of 82 millimeters. Okay? As you can imagine, for the passenger, is a huge value. After this, we decide to change the structure. And how we change the structure? We introduce these beams, as you can see here, and we introduce a reinforcement Y to decrease the displacement in this direction. And for this intermediate model, we use a main profile from steel with 30 by 30 by 3 millimeters, The reinforcement materials is also a steel with 3 mm thick, and the total mass is more or less 7 kilograms. And here we obtain a massing displacement in the headrest zone of 17 millimeters. And in this moment we decide to optimize the model. And to optimize the model, we define these variables and these constraints. In terms of variables, we define the end models and the Poisson coefficients for the two materials, steel and aluminum alloy, the dimension of the main profile, okay, this one in green, the width and the thickness, and the dimension of the reinforcements, namely the length and the thickness. In terms of the constraint, and this is very, very important, we define a total mass for the structure of 5.5 kilograms, a displacement, a maximum displacement of 35 millimeters, and a maximum value for the foam is 60% of the yield stress, namely for the steel and for the aluminum alloy. And if you look, the final model is more or less the same in terms of looking of the intermediated model, but in terms of the materials, in terms of the dimensions, and in terms of the massing displacement are very, very different. Just a moment, I need water. Which is the difference? The main profile here is not steel, it's not from steel, but aluminium with 40 per 40 per 0.5 millimeters. The reinforcement materials, of course, is steel, and we keep the 3 millimeters thick. The total mass decreased for more or less 4 kilograms, and the maximum displacement, it was about 29 millimeters. The second part of the study, it was to define the sensors that we want to apply in the structure. We use the finite elements analysis to locate the points with higher values in terms of stresses, and it was here in this location, in the reinforcement, and we decide to bond, to connect strain gauges in a full bridge in this location. In this moment, as you can imagine, we are trying to obtain the sensors, and we have a few problems with this. The second one is the second type of sensors, it was accelerometers, and we will connect accelerometers in these directions and locations, and here we will perform experimental tests in labs, and after this in service conditions inside the train. And finally, for the comfort of the passenger, we will connect a microphone in the headrest to obtain the noise level. Concluding, here we can see the values in terms of the first, the second, and the final model that we studied. In red, we have the values that are higher than the constraint defined, and if you look, the final one is the only model that respects all the constraints in terms of the total mass defined, in terms of the maximum displacement of the headrest, and the maximum from its stresses. And that's all. Thank you for your attention. And of course,
thank you very much. Other questions? or comments? Yes, please.
This optimization process to get from the intermediate to the final.
We have a lot from the intermediate.
Yeah, but did you do that by hand or did
No.
you run a computer program?
We use a program that was developed by Aguilar Madeira. It's GLOTS. Maybe you don't know GLOTS. It's a program that it was developed inside Instituto Superior Técnico, and it's a mathematical model, okay? And we have a connection between GLOTS and, in this case, Alves, to obtain the final configuration and the final model. And this is the explanation, of course. In terms of the constraint, we define the type of profiles, only standard profiles. For example, it's impossible to have a beam profile with 33 per 32. Now we define standards 30 per 30 per 2 or 40 per 40 per 3, and we perform the analysis and we obtain this kind of results. And in this moment, this is very important because this structure will be present in InnoTrans. Do you know InnoTrans, the fair in Berlin next September? No? Okay. It's very important for the railway sector, this kind of demonstration, and we will present the current seat and we will compare in terms of the sensors, the displacements and the stresses with the optimized structure. The structure in this moment are in the manufacturing process.
Further questions? Yes, please.
Hello, Professor Virginia. Yes, well, just for the sake of curiosity, what kind of finite elements did you use? Tetrahedron, hexahedron?
I don't know, okay? Because I'm in the design part, okay? I'm not in the finite element analysis. This part was performed for another colleague, Federico Alves. I don't know the details. I know that we use Alves and we compare with the NX and X program, and the results are more or less the same. But in terms of the detail, I don't know.
Thank you so much.
Thank you.
Further questions? Yes, please.
You said that you were currently manufacturing the structure. How are you manufacturing them and joining them the parts later?
In this moment, we want only one prototype, okay? And as you can imagine, we are perform a lot of simplifications and assumptions. I can show you. For example, in this part, okay, I have, because this part, the brown part is from steel, and we have two plates, and after I will change the configuration of the plates, and in the end I will weld this part, okay? Because it's a prototype. Of course, in the end, we must use a different type of tools. These are performing in this moment by MCG. Is a huge company, manufacturing company in Portugal, Manuel da Graça, and they are studying how they can connect. But in this moment will be a prototype. The big difference for sure is this one, as you can imagine, is introduction of aluminum alloy in this structure, in the green one. And to introduce aluminum alloy, we need to introduce the black one by steel, the reinforcement.
Okay, thank you.
Okay,
Thank you
sorry.
again.
Okay, thank you.